Hello Physical Science. We are moving on to our last section in Chapter 2, and the title of this section is Chemical Properties. So last section we learned about the physical properties, and we also learned about physical changes, and in both of those all involved, again, just changing things kind of almost on a surface level when we talk about a physical change, about how it really has nothing to do with the composition of the matter. And when we get into chemical properties, that's going to where we start getting into when the composition and actually the makeup of our matter is changed. So as always, we start with a little example to help us introduce here, and it's talking about candles. So it said, how would you describe these candles to start? So first we have color, hardness, and density are all physical properties, again we talked about, that we can use in our description. You can also say that the candles are burning. And this is where we kind of start to get a little bit new. The ability to burn is not a physical property, because as a candle burns, new substances are formed. So that is going to be one of the, again, the telltale characteristics of a chemical change, is when the substances, again, start to change or new ones begin to form. So when will our actual chemical properties be observed? So again, going back to our example, as a candle burns, its compounds combine with oxygen in the air to form water and CO2, so our carbon dioxide, CO2, carbon dioxide. So a chemical property is any ability to produce a change in the composition of matter. So I would definitely write that down. So again, our physical properties are things that are observed without any change being made to the actual composition, and a chemical property, again, is any change, is kind of the exact opposite of that, if it's the ability to produce a change in the composition of matter. And our two examples we're going to talk about, first one is flammability, which again was just mentioned a second ago with the candle, and reactivity. So those are our two chemical properties, and we're going to hit on both of those. Looks like right now. So again, chemical properties can be observed only when the substances in the sample of matter are changing into different substances. So this is when we are going to see our chemical properties, when they are again changing into different substances. So again, flammability is going to be our first one. Materials that burn can be used as fuel. Flammability is a material's ability to burn in the presence of oxygen. So I would definitely write down flammability. And again, if you did not know this, oxygen is highly flammable, and it is like kind of the driving source behind any fires or anything that we have. So flammability, material's ability to burn in the presence of oxygen. And reactivity is the property that describes how readily a substance combines chemically with other substances. So when we put, again, two substances next to each other, does it cause an explosion to happen? Does it cause nothing to happen? That is how we describe reactivity. So we have flammability and reactivity, and we'll get a little example here, I believe. Okay, so this is an example of reactivity, is rust. So rust will form when oxygen reacts with iron and water. Rust is a brittle reddish-brown compound, and because iron is highly reactive, you would not choose iron to make jewelry or coins. So this is what happens. Again, iron is strong, however it is highly reactive, so we wouldn't want to use it on things that are going to be, again, passed around a lot and things like that. So rust, again, being on any type of metal, that is a chemical property or a chemical reaction that has occurred. So rust, again, it occurs when oxygen reacts with iron and water. And also another example is, again, of reactivity, has to do with nitrogen. So nitrogen has many uses that depend on the fact that it has a very low reactivity. So nitrogen, if you did not know, makes up most of the air that we breathe, which is good, because if it did not have a low reactivity, then we would not have a very stable atmosphere. So the fact that nitrogen has a low reactivity is good. And researchers in Japan, because they know nitrogen has a low reactivity, they've pumped nitrogen gas into the steel tanks that hold seawater in ships, and this nitrogen displaces the oxygen dissolved in the water, and it prevents rusting. So this is, again, a good practical way of knowing, or of why we need to know what chemical properties are, because again, the nitrogen comes in, it is not as reactive, so it keeps the oxygen from reacting with the water and causing rusting. And so that is, again, nice short video there to start section 3. Let me know if you have any questions.